Hello students, all of you are doing good? Okay, so today we are going to learn ratio and proportion. This is a chapter I have divided this chapter into 2 or 3 videos. I will actually explain the entire ratio and proportion concept. By this time probably you have heard about these two terms, ratio and proportion, but a lot of people they gets confused with these two terms and they almost use ratio and proportion symmetrically, but it's not so. So what we are going to cover in today's first class, we are going to cover what is ratio, what is proportion, and what is the difference between these two with examples, real life examples, right? And then we are going to cover types of ratio, different types of ratio are there. We will cover this and along with example, and third one we will do some sort of hands-on on the entire chapter what we are going to discuss today. Okay, so let's start. So what is ratio? This is the term we use, I mean, in mathematics, in science, in our day-to-day life, everywhere we use this term ratio, very common term. So what is ratio actually? Ratio is nothing but the comparison between two same kind with same unit. What is this? Let's understand it. So ratio is comparison between two quantities of same kind. This is a very important term. Same kind, two quantities of same kind and same unit. What does it mean, same kind and same unit? Let's say, can you compare weight with distance? Can you compare age with height? No. Age is one entity, one type of entity. Height is another type of entity. Weight is one type of entity and distance is another type of entity. So the comparison can be done between two same kind of entities, right? So let's say there are two entities, age and distance. Can you compare between age and distance? Age versus distance comparison, is it possible? No. These two are two different kind of entity. This same kind, should be same kind. Can you compare weight versus height? No, you cannot. So weight and height, these two different kind of entity. But so age versus distance, not possible. Weight versus height, not possible. So what is possible? It is possible age versus age. Is it possible? Yes, it's possible. Weight versus weight. Is it possible? Yes, it's possible. So age versus age, these two are two same kind of entity. So this is satisfying. Weight versus weight, satisfying. But this is still we cannot say is it possible or not. Because if it's said, let's say age 1, A1 equals to 30 years. Right, and age 2, A2, this is equals to 50 months. Can you compare between A1 and A2? You cannot, because these two are same entity. This is also age, this is also, it is age 1, this is age 2. These two are age, both of these are age, but unit is different. These two are not same unit. One is years, one is months. So either you need to convert age 1, A1 from years to months, or you need to convert 50 months, A2 to years. So either it should be, both of these should be years or both of these should be months. So therefore these two terms are very important. Ratio is the comparison between two quantities of same kind, with same unit. Now you can compare weight W1 equals to 50 kg and weight W2 equals to 30 kgs. Can you compare? Yes, you can compare, because both of these two are weight. That means this is same unit, same kind, and this is same unit. So if the kind are same and if the units are same, then you can compare between two entities. That is what? Ratio. Now, how can we represent ratio? Representation of ratio can be in the form of division, that is fraction, or in the form of, let's say, A equals to 30 kg, B equals to 50 kg. You can compare these two. Either you can say A by B equals to 30 by 50, because kg. Why the same unit should be there? Because 30 kg versus 50 kg, these units are cancelled. So what is this fraction? It is 3:5, 3 by 5, right? Either you can represent in the form of A by B, 3 by 5, or you can also read like this: A is to B. A is to B, A will come first, 3:5. So how you will read it? What in the form of ratio, if it is given, even though it is given A by B equals to 3 by 5 or A is to B equals to 3:5, what you will read like this: A is to B equals to 3B equals to 3:5. 3:5. That is how you read. A is to B equals to 3:5. So this is nothing but fraction. But why the same unit should be there, you can understand, because if the unit is same, in the reverse way you try to understand. If the kg is the unit of weight, so ultimately if the unit is same, automatically the kind is also same, because for we know the unit centimeter, millimeter, kilometer, meter, all these are unit of length or distance or height. Length, distance, height, all these are similar kind of entity, right? Because the unit is same. Kg, this is used to represent weight. So if the unit is same, by default the entity kind is also same, right? So why the unit has to be same? Because that is how it will cancel the unit. Because if you say 3 kg by 50 gram, you cannot compare. That is where, so in reverse we can say, if the two quantities of same unit can be represented in the form of division or fraction, then we can say it's a ratio. So if the same unit it is there, by default automatically the kind is also same. That is what ratio. Now I will give you couple of examples in real life scenario. Let's say it is said in your class you have total 200 number of students, combining all your sections, all the sections A, B, C, D. So all the total number of students is 200, and the ratio of boys and girls in the class, it is 2:3. We'll say boys is to girls, this colon that is used, is to, boys is to girls, means ratio equals to 2:3. Then what is the number of boys, what is the number of girls? One thing also you need to remember, if I say boys is to girls equals to 2:3, that doesn't means boys equals to 2 or girls equals to 3. No, this is not correct. So what is correct? Correct is boys equals to, let's say you assume boys equals to 2k and girls equals to 3k. Total number of boys is 2k. Depend k is the variable where k not equals to 0. So if the ratio is given, you can assume like this: boys equals to 2k, girls equals to 3k, where k not equals to 0. Now total number of students is 200, right? So what is the number of boys, what is the number of girls? You can do it in two different ways. How you can do it? You remember fraction. If the total number is given and the ratio fraction is given, now how you can do that? Boys equals to 2/5 2/3 means the number of boys is 2/5 of the total number of students. If we assume the total number of students is 1, that means the boys is 2/5 of the total number of students and the girls is 3/5 of the total number of students. You remember the fraction when you did it in class 5 or 6, right? So boys equals to 2/5 into total number of students 200. So 200 means it is 40. So boys, number of boys is 80 and number of girls is 200 into 3:5. Girls is 3. Total 3. Total is the 3/5 of total number of students is girls. So girls is 200 into 3/5. That is 120. This is how we can do that. So boys and girls, you just use the concept of fraction 2:3. Let's say boys equals to 2k and girls equals to 3k. So total number of boys and girls, it is how much it is? 2k plus 3k. Total 2k plus 3k equals to 5k. Now you determine the value of k. 5k equals to 200. 5k is the total number of students. Here also total number of students 200. So 5k equals to 200 or k equals to 200 by 5 equals to 40. So if you know the value of k, just replace the value of k here. It is boys equals to 2 into 40 equals to 80 and girls equals to 3 into 40 equals to 120. So this is the two ways you can do that. In your class, total number of students is not given. The boys is to girls equals to 2:3. Number of boys equals to 80. What is the total number of students and what is the number of girls? Now, so number of boys is given, boys and girls ratio is given. Now, you assume boys equals to 2k equals to 80 or k equals to 80 by 2 equals to 40. You know the value of k. So what is the number of girls? Number of girls is 3k equals to 3 into 40 equals to 120. So the question could be number of boys is given or number of girls is given, whatever it is so, and the ratio it is given of boys and girls, and then you find out if the number of boys are given, then find out the number of girls. You find out the number of girls, or it's asked what is the total number of students. So if the boys and girls are, so k value is already you know, k is 40, right? From the 2k equals to 80. 2k equals to 80, you know the value of k. Either if the number of girls is asked, you can straight away find it like this. If the total number of students it is asked, then total number of students is 2k plus 3k equals to 5k. Then 5 equals to 5 into 40 equals to 200. So different ways of representation could be there, but the ratio, the meaning of ratio is you can compare two quantities of same unit. If the unit is same, automatically the kind is also same, right? So that is what ratio, and that is the one of the real life example I have given you. Now let me tell you what is proportion. Then I will come with another real life example. Whether the ratio is given, you need to understand, you need to find out the proportion. What will be the amount, quantity, right? So proportion. Proportion is, here ratio is just representing two quantities of same kind with and same unit. Proportion is if you have multiple ratios equal, the equation it is there. So you need to represent multiple ratios. Let's say I am giving you first of all very simple example. Let's say 2 by 5. If you remember in your fraction or in rational number in class 8 or in fraction in class 5, 6, you understood what is equivalent fraction or what is equivalent rational number. Just try to remember. So if the fraction or rational number it is given 2 by 5, find out the equivalent fraction. So you can multiply both the numerator and denominator with the same number, and in that case the fraction remains same, and that number is called equivalent fraction. Let's say if I multiply both numerator and denominator with 2, that means 2 into 2 by 5 into 2, same, but the number it is 4 by 20, 4 by 10. Or we can say 2 into 3 by 5 into 3, that means 6 by 15. This is also actually, so this is the least fraction, and 4 by 10, 6 by 15, these are equivalent fraction of 2 by 5. That's the concept it's used. If the two ratios are equal, then we can say this is a proportion. So let's say A is to B. One ratio it is given where A and B are of same kind and same with same unit. Another ratio is given C is to D, where C and D are also same, not necessarily A, B, C, D, all the four entities has to be of same kind and same unit. AB is of same kind, maybe or may not be, but AB has to be same kind and same entity, because same kind and same unit, because it's a ratio. C is to D, C and D are also of same kind and same unit. So, but if these two values, if A is to B equals to C is to D, let's say A is to B equals to 2 is to 3, and C is to D equals to 6 is to 9. That means A is to B equals to C is to D, because C is to D 6 is to 9 means actually it is 2 is to 3. So if A is to B equals to C is to D, we can say, so how we'll read it out proportion? A is to B as C is to D. That's how you need to read. A is to B as C is to D. So the value of A is to B is equal to the value of C is to D. That is what proportion. Now you may ask, what is the use of ratio and proportion both in real life example? Let me give you an example. Now let's say in a cooking recipe, let's say khichdi. You know, everyone knows khichdi. The proportion, ratio of preparing 200 grams of khichdi of 200 grams. The recipe is given, you know, all of you know. The ratio is given. Based on the ratio you need, you can cook anything. Just you need to understand what is the ratio of the ingredient, and then you need to understand your cooking knowledge. But the recipe has to be given, right? So khichdi of 200 grams of khichdi, the ingredients, main ingredients I'm talking about here, rice is to dal is 2 is to 3. Rice is to dal is 2 is to 3. This is the ratio that is given. But not necessarily always you will prepare only 200 grams of khichdi. You may need to prepare 1 kg khichdi, 800 gram khichdi, whatever it is so. But the ratio of rice is to dal has to be with the same ratio. That means the rice and dal, if the khichdi will be 500 gram, let's say the khichdi, you need to prepare khichdi of 500 gram, then how much rice and dal you will use? So you need to proportionately increase the quantity of rice and dal, because the quantity of khichdi it is increasing to weight is from 200 to 500. So automatically you need to increase both the quantity of rice and dal. And how will you increase it? Proportionately with this ratio. That means the rice and dal has to be with the same, proportionately it will increase. That means in the newly prepared khichdi of 500 gram, the rice is dal also has to be with the same ratio. That means this is where called proportion comes into picture. So now if I say, just forget about this part, proportion part, just 200 grams of khichdi. To make 200 grams of khichdi, you need to have rice is to dal 2 is to 3 ratio. Then how much rice and how much dal it is needed? to prepare 200 gram khichdi. No proportion is coming into picture, only ratio. So you need rice equals to total quantity of khichdi 200 into rice is 2/5 of the total khichdi. That means 80 gram. You need rice 80 gram and dal, it is 200 into 3/5. 2:3. So 3/5. This is absolutely in the concept of fraction. What you know already. So 40 into 3 equals to 120 gram. So to prepare 200 gram khichdi, you need 80 gram of rice and 120 gram of dal. So now, to prepare khichdi of 500 gram, how much rice and dal it is needed? This is the given ratio. This is the cooking recipe. This one is the recipe. Because when someone gives the recipe, they need to tell the ratio against the same quantity, against the total quantity of the product or total quantity of the item, right? So khichdi of 500 gram, if you need to prepare, how much rice and dal you need to give? You need to give, add rice equals to, proportionately you need to increase. This is where proportion comes into picture. So rice equals to 500 into 2/5 equals to 200 gram. And dal equals to 500 into 3/5 equals to 300 gram. Right? So in here itself, now we are comparing these two ratio. So 200 is to 300 equals to, earlier it was 80 is to 120. These two are same proportion of 2/3. Both of these are equal to 2/3. So that means these two are in the same proportion. So if the two ratios are equal to each other, two quantities, so these two ratios are same. So these two are in proportion. So that is the use of or let's say proportionately the population of the country is increasing. So that means with the same ratio it is increasing. With the same ratio. When I say same ratio, that means everywhere the ratio is same. That means you are comparing ratio of each time. So that is what proportion comes into picture. Okay. So before I move into types of ratio. Now you understand difference between ratio and proportion. Now we will move to types of ratio. Before that, I need to repeat one thing once more. That is, what did I say? If A is to B equals to 3 is to 5, you cannot say A not equals to 3 or B equals to 5. But you should say A equals to 3K and B equals to 5K. If K equals to 1, then A equals to 3 and B equals to 5. But not necessarily always A and B, A equal to 3 and B equals to 5. So the ratio based on the value of the K, it depends what will be the value of A, what is the value of B, so that the ratio between A is to B, between A and B will be 3 is to 5. You need to remember this to them. Don't make the exact value, always multiply the variable or the variable factor and find out the factor to determine the value of that A and B. Got it? Now the types of ratio. First we will explain what is compound ratio. If there are multiple ratios, like one ratio is A by B, or you can say A is to B, whatever it is. So A by B, C by D and E by F. There are, let's say, how many number of, whatever could be the number of ratios. So there are different ratios, A by B, C by D, E by F. Now you are asked to find out the compound ratio of the given ratios. So compound ratio of the given ratios will be, for A by B, C by D and E by F, the compound ratio will be A by B into C by D into E by F. That is actually the multiplication of the numerators, or you can say antecedents. So compound ratio of the given ratios is equal to product of antecedents or its numerator of the fraction term. Actually antecedents means numerator, and divided by product of consequents or denominator. That means for A by B, C by D, E by F, for three given ratios, the compound ratio will be A into C into E divided by B into D into F. So A into C into E divided by B into D into F. That is what compound ratio, right? Now it is duplicate ratio. Compound ratio of two equal ratios is duplicate ratio. What is duplicate ratio? Compound ratio of two equal ratio. Here A by B, C by D, E by F are not equal. But if the ratios are equal for two given ratios, if the ratios are equal, then the duplicate ratio will be the square of that ratio. So if I say there is one ratio A by B, another ratio is C by D, what will be the compound ratio? Compound ratio will be A by B into C by D, because I said compound ratio means multiplication of the numerator of, or antecedents divided by product of consequents or denominators. That means actually you are multiplying the ratios. So A by B and C by D, if these two are ratios, the compound ratio of these two will be A by B into C by D. Now if A by B equals to C by D, so what it will be? It will be either A by B into A by B or C by D into C by D. So that means A square by B square or C square by D square. So the duplicate ratio of two given ratios is nothing but the compound ratio of these two. So if the compound ratio of two equal ratios is called duplicate ratio. Now what is sub-duplicate ratio? So if you are asked what is the duplicate ratio of A by B, you will say the duplicate ratio of A by B will be A square by B square. Duplicate ratio of 2 by 3 equals to 2 square by 3 square, that means 4 by 9. Now sub-duplicate ratio. Sub-duplicate ratio, so it is square of the one of the ratio is duplicate ratio. What is sub-duplicate ratio? Square root of that ratio. If you are asked to find out the sub-duplicate ratio of A by B, it will be square root of A by square root of B, or you can say square root of A by B. So duplicate is squaring that ratio, sub-duplicate is square root of that ratio, right? Similarly, triplicate ratio, you can understand from the name. So if three ratios are equal to each other, so compound ratio of three equal ratios. In duplicate ratio, we understood compound ratio of two equal ratios, which is the square of any of the ratio, square of that ratio. Triplicate ratio is compound ratio of three equal ratios, which is equal to the cube of the ratio. That means if there are three ratios, A by B, C by D, E by F, and A by B equals to C by D equals to E by F, then what is the compound ratio? Compound ratio will be A by B into C by D into E by F. That means either you can say A cube by B cube or C cube by D cube or E cube by F cube. So compound ratio of three equal ratios is the cube of any of the ratio. That is what triplicate ratio. That means if you are asked to find out the compound triplicate ratio of 2 by 5, which will be equal to 2 cube by 5 cube equals to 8 by 125. Now similarly, like sub-duplicate ratio, duplicate it is square of the ratio, duplicate it is square root of the ratio. Similarly for triplicate it is cube of the ratio, and sub-triplicate is if the ratio is given a by b and you need to find out the sub-triplicate ratio, that means cube root of sub-duplicate square root of the ratio, and sub-triplicate is cube root of the ratio, cube root of a by cube root of b, that is equals to cube root of a by b. Understood? Very simple thing. So now if the cube, if you are asked to find out the sub-triplicate ratio of 8 by 125, here it was triplicate, so sub-triplicate it will be 2 by 5. From 2 by 5 you got triplicate ratio 8 by 125. If the ratio is given 8 by 125 or 8 is to 125, what is the sub-triplicate? Cube root of that, that means 2 by 5 or 2 is to 5. Okay. Next one is number 6, reciprocal ratio. Reciprocal ratio, from the name itself it is clearly understood, it is the reciprocal of that. That means you need to flip reciprocal rational number, reciprocal number. So if the ratio is given a by b, the reciprocal ratio of a by b is b by a. That means actually it is the reciprocal a by b by a, actually b by a equals to 1 by a by b. 1 by that. That means you are flipping the numerator and denominator. That is what the reciprocal ratio. So what we understood? There are 6 types of ratios mainly. Number 1 is compound ratio, which is the multiplication. Compound ratio of multiple ratios is equal to the product of all the numerators or antecedents divided by the product of all the consequents or the denominators. What is the duplicate ratio? Duplicate ratio is the compound ratio of 2 equal ratios, which is in turn the square of the ratio, which is sub-duplicate ratio. Number 3, sub-duplicate ratio is the square root of the given ratio. What is triplicate ratio? Triplicate ratio is the compound ratio of 3 equal ratios, which in turn the cube of the given ratio. What is sub-triplicate ratio? Sub-triplicate ratio is the cube root of the given ratio. If the ratio is a by b, the sub-triplicate ratio will be cube root of a by b. What is reciprocal ratio? It is the reciprocal of that particular ratio. The ratio is a by b, that means the reciprocal ratio will be b by a. That is all the types of ratios. You will have exercise or example when I will come to this part. But before that I will explain few of the major properties of ratio also. Now I will discuss few of the major properties of ratio. Let's say one ratio is given, A is to B. Let's say one ratio is given, A is to B equals to 2 is to 3, and B is to C equals to 3 is to 5. Then you can say, that means this B part is common in both the ratios. Here also it is B, here also it is B. Here also value of B is 3, here also value of B is 3. So if there are one common entity in each of the ratio, in one entity is common in 2 ratios and the value of that also is same, in that case you can write down A is to B is to C equals to 2 is to 3 is to 5. 3 is common. If A is to B equals to 2 is to 3 and B is to C equals to 3 is to 5, entity B is there both the cases and the value is same both the cases 3. That means you can say A is to B is to C equals to 2 is to 3 is to 5. Got it? That is one thing. But if the entity is common, if the value is not same, but you are asked to find out A is to B is to C, what you need to do? let's say here it was both the cases B, but the value was earlier cases 3, but it is here it is not same. Let's say A is to B is equals to 2 is to 5, B is to C equals to 3 is to 5. Now the entity is same B, but the value here what is B in the ratio? It is not value exactly. B is here it is 5, here it is 3. Now you need to make these two equal. How you can do it? You remember the fraction, while you will do fraction, addition, subtraction like that, or you compare between two fractions where the denominators are not equal. What you are doing? You need to make the denominator common. So here it is not denominator, but the unequal part you need to common. So if you need to make the part unequal part common, how you will do that? You need to find out the LCM of this. So LCM of 5 and 3, LCM of common entity. So what is the LCM of common entity here? B is the common entity. What is the value? B and 5 and 3. So LCM of common entity B, what is the value? The value it is here, LCM of common entity B is 15. 3 into 5 equals to 15. So now you need to make this B part 15 for both the cases. So you are asked to find out A is to B is to C. You cannot straight away write down 2 is to 5 is to 3 is to 5. So A is to B is to C. First you need to do A is to B, that is A by B equals to 2 by 5. You need to make 15. B, you need to make B 15. So what you need to do? You need to multiply 5 with 3. Here also in the fraction, if you multiply both numerator and denominator with the same value, the fraction remains unchanged. So 2 into 3, that is equals to 6 into 6 is to 15. Right. Now here it is given B is to C equals to 3 is to 5. So here also you need to make this 3 to 5. B here it is now 15, you need to make it 15 also. So what you will do? 3 by 5, make 3 15, that means 5 you are multiplying with 5. So if you are multiplying numerator with 5, you need to multiply denominator also with the same number, that is 5. That means it is 15 is to 25. 15 by 25. Now you have the common value here, right? So what is it? A is to B equals to 6 is to 15. B is to C equals to 15 is to 25. That means A is to B is to C based on the property. If the B value is same, the common entity is same, then you can straight away write down like this. A is to B is to C equals to this 2 15 is now same. This is also 15. This is also 15. So you can write down A is to B is to C equals to 6 is to 15 is to 25. So if in the reverse way, if the ratio is given A is to B is to C equals to 16 is to 15 is to 25, you can write down straight away. You can write down, compare this to A is to B, you can say 6 is to 15. B is to C, you can say second and third. B is to C equals to 15 is to 25, and A is to C equals to A by C, it is 6 by 25. So A by B, A is to B, you can write in C, 3 2s are 6, 3 5s are 15. So 2 is to 5, 2 is to 5. B is to C, 15 is to 25. Common factor is 5. 3 5 5 3s are 15, 5 5s are 25. 3 is to 5. B is to C, 3 is to 5. A is to C is not given. Straight away you can find out here also. 6 is to 25. So now let's say you are not asked to find out A is to B is to C. You are asked to find out A is to C. That means you need to find out A is to B is to C first. The ratio between these three, then straight away you can take it A is to C equals to 6 is to 25 from there. Got it? Now the second property. Let's say there are three given ratios. A by B, C by D, and E by F. And these ratios are equal to each other. A by B equals to C by D, E equals to E by F. Then each of the ratio will be equal to the sum of the numerators or antecedents. That means A plus C plus E by B plus D plus F. So if three ratios or three or more ratios or two or more ratios are equal to each other, if two or more ratios are equal to each other, then each of the ratio will be equal to the sum of their numerators by sum of their denominators. This is another property. So these two property you need to remember. These two will be useful in many of the problem sum. So now we will do few problem sums on ratios, right? See this example. If A by B plus C equals to B by C plus A equals to C by A plus B, then prove that there are two questions. One is each ratio is equal to -1 if A plus B plus C equals to 0. Each ratio is equal to that means A by B plus C equals to B by C plus A equals to C by A plus B equals to -1 if another condition is given, A plus B plus C equals to 0. Second one is each ratio is equal to half if A plus B plus C not equals to 0. Right? So now we will do number 1 first. A. We'll start this A plus from A plus B plus C equals to 0 part, because another condition, one is the equality, another is A plus B plus C equals to 0. So what you need to do? A plus B plus C equals to 0 means you can find out, you can say just each of the cases you find out the denominator. B plus C equals to, if A plus B plus C equals to 0, that means then B plus C equals to minus A, C plus A equals to minus B, and A plus B equals to minus C. Just here, A plus B, C is going to that side, minus C. Changing the sign side of the equation means changing the sign of that item. B plus C equals, right? Okay. Now you just replace those values. That means A by B plus C, this one I am taking. A by B plus C equals to A by minus A. B plus C equals to minus A, that means minus 1. Similarly, B by C plus A B by C plus A equals to B by C plus A is minus B, that means minus 1. And C by A plus B equals to C by A plus B equals to minus C, that is equals to minus 1. That means A by B plus C equals to B by C plus A equals to C by A plus B equals to minus 1. Number A is solved. So this is number A. That means A by B plus C equals to B by C plus A equals to C by A plus B equals to minus 1. Right? Now, second one, the condition is given A plus B plus C not equals to 0. That means you cannot say B plus C equals to minus A. If this is not equals to 0, you cannot say that. So what you will do for the second example, you remember the property, what did I say? If two or more ratios are equal to each other, that means each of the ratio will be equal to the sum of their antecedents or numerator divided by sum of their denominators or consequents. That means what I can say, A by B plus C equals to B by C plus A equals to C by A plus B equals to sum of their numerators divided by sum of their denominators, right? So what will be? That means A plus b plus c, sum of the numerators or antecedents, and sum of the denominators is a plus b plus c plus c plus a by b. That means b twice, c is also twice, a is also coming twice. So that means it is b plus c plus a plus b equals to a plus b plus c by 2 of a plus b plus c. So you will just cancel, that is equals to half. So each of the ratio will be equal to half. This is number B. So A and B resolved. Okay. See, this is another interesting example. First you understand the problem. Given x is to y is to z equals to 2 is to 24 is to 100. This is the given condition. X is to y is to z equals to 24, 2 is to 24 into 100. When you read out a problem sum, I hope you know by this time already, main condition you need to focus upon. So this is one given part. Now values of x, y, z changed in such a way that x is to z is doubled and y is to z is halved. If the new value of x is 24, then what is the new value of y? First of all, you just assume the new values are x1, y1 and z1. And another condition, the given condition already I have said, if the ratio of more than 2 ratios is given, then you can find out any of the ratio from there. That means if xy is to y is to z is given, 2 is to 24 is to 100, you can find out from this given ratio what is x is to y, what is y is to z and what is x is to z. You can find out x is to y is 2 is to 24, y is to z is 24 is to 100 and x is to z is 2 into 100. Right? That already I have shown you. Right? Now the condition is given x is to z is doubled. That means that assume, and what are the new values of y? That means you need to find out y1. So first you understand the given condition. The x is to z is doubled with the new value of x1 and z1. That means x1 is to z1, these are the new values, equals to 2 of x is to z. That means 2 of, what is the x is to z value? X is to z is, from the given condition, x is to z is 2 is to 100, 2 is to 100, and another y is to z is halved. So what is the current y is to z? Y is to z equals to 24 is to 100, 24 is to 100. So new, as per the new value, x1 is to z1 equals to doubled of earlier x is to z. That means 2 of x is to z equals to 2 into x is to z is 2 is to 100. That means 2 by 100. So 2 by 100 equals to 4 by 100. That is x1 into z1. So now x1 is given 24. So how much is z1? Z1 equals to, from this equation how you can find out? So x1 by z1 equals to 4 by 100. So from here you can find out z1 equals to 100 x1 by 4 equals to 100 into x1 is 24, 24 by 4 equals to 600. So current value of z1, current value, new z1 is 600, but you need to find out. So x1 is given, new value of x is, that is equals to x1 24, new value of z is 600. Now what is the new value of y? So What is the new value of y? That means y is to z. That is halved. That means y1 by z1 equals to half of y by z. Y is to z. That means y by z equals to half of y by z is 24 by 100. 24 by 100 equals to 12 by 100. Right? Then from here we can say z1 equals to 100 y1 by 12. Sorry, you need to find out y1. New value of y. You need to find out new value of y. That means y1. So what is, how much is y1? y1 equals to 12 into z1 by 100. That means 12 into z1 is 600. 600 by 100. So 100, 600, 6, that is 72. So new value of y. So new value of y is 72. This is what the new value of y. That is equals to 72. y1 equals to 72. So which property of ratio it is used here other than normal application of mathematics? This is used if the ratio is for more than two ratios are given altogether, you can find any of the two ratios from the given ratio. That is what we have used. x1 xy is to y is to z is given. That means you can find out x is to z, the current ratio of x and z, current ratio of y and z, and then from there based on the condition you find out the y1, new value of y1. Right? So that is how few of the examples I have done in this particular video. I will make another video at the end of proportion, because the next video will be on proportion, and then I will make another video where basically we'll do few more hands-on where it will cover both ratios and proportion. Right? So I hope you understood the ratio part and the difference between ratio and proportion, and how we use ratio and proportion, these two terms, in our real life scenarios also. Right? So if you like this video, please click on the like button, and if you want to have this kind of video once and again, please subscribe my channel. Okay, thank you.